Lesson 31. More derivatives. This is specifically the product rule. Okay, so how to handle taking a derivative when there is more than one function multiplied together. So when there is a product, how do we take the derivative? Okay, so it's not as easy, unfortunately, as just, oh, I see this, I know that derivative, I see this, I know that derivative, and just take those derivatives. That works when we have multiple pieces that we are adding. We can just take the derivative of each item that we are adding together. But when it comes to multiplication, it doesn't work like that. So we have this item called the product rule. Okay? And the idea of the product rule is if you have two pieces, f and g, so two functions, in order to take the derivative, you'll notice it says f prime g plus g prime f. And so the product rule, you take the derivative of the one, keep the other. Like multiply those together, and then plus, and then you're going to flip-flop. So whichever one you didn't take the derivative of the previous time, you have to take the derivative of now and multiply by the original. Okay? So, we usually say derivative of the first, keep the second. And then it's derivative of the second, keep the first. But it doesn't matter. Order is not going to matter of which derivative you take first in the product rule. Okay? So that's what we're doing. So, we're practicing that all day. Example 1. Let y equals x squared sine x, and they want us to find y prime. I think what might be a little helpful is think about what represents f and what represents g. In your brains, what is f? Okay. And what is g? Sine x. Okay, so when we do this, if we follow this, it's f prime g, so derivative of f, keep g, plus g prime f. Derivative of g, keep f. So I'm going to write this out here. Y prime equals, so f prime, derivative of f. What's derivative of x squared? 2x. And then we're going to keep sine x. And then when it's a product rule, unless you have a negative in your derivative, we always add here. And this time, derivative of g. So what's the derivative of sine? Our derivative of sine of something is cosine of something times f. So times the original, which was x squared. How did I write this? Okay, about the only thing I've done from here is just cleaned it up. And I have mine written as 2x sine of x plus x squared cosine of x. Depending on the situation, it is possible if there's a GCF that they'll factor out the GCF, which there is a GCF of x here, but it doesn't really simplify it any. So we would just leave it as is. Or at least that's what I'm doing right here. Questions? Derivative of the first, keep the second. Plus, derivative of the second, keep the first. Just alternate. Okay, we're going to try example 2 then. F of x equals x squared e to the x, and we're trying to find f prime of x.
So f is x squared and g is x. So f prime of x would just be 2x e to the x plus x squared e to the x.
That's a really fast version, but yes. The key is, are you guys all caught up with him, or are you guys still trying to process? So if we go derivative of the first, which I don't usually refer to them as f and g once we get into this, but derivative of the first, so derivative of x squared is 2x. Keep the e to the x. What sign goes in the middle? Plus. And now, this time, it's derivative of e to the x. What's derivative of e to the x? E to the x. And then keeping the x squared here. Okay, and I probably am not doing, realize why are we applying the product rule? This one because it was x squared and sine x. This one because it was x squared and e to the x, right? If you have to take the derivative of two things side by side, you have to use the product rule. Now, I believe this is a good one to practice factoring out a GCF. What do 2x e to the x and e to the x squared have in common? E to the x and an x. So the GCF I actually have factored out here is x e to the x. And if I factor out x e to the x, that leaves me with a what for the first term? 2 plus, what about the second term?
2 plus
Plus x. So 2 plus x in parentheses. Does that make my first answer wrong if I stopped at the first answer? It does not. Okay? Equivalent forms. I mean, if we go back to a basic multiple choice problem, if you get the first answer but they have the second answer, are you able to recognize, oh, hey, they factored it. I didn't factor mine.
So for the first one, we could have done x.
Yes, we could have factored out x on the first one. First one just wasn't as common because it doesn't really clean it up as nicely. This one cleans it up a little bit nicer. And I feel like this is factoring out that x e to the x is something that comes up in future problems. So, okay, example 3. Let u equal natural log of x, v equals 2 e to the x, and y equals uv. Find y prime. My recommendation, and there's a couple of different ways we can do this, but what is y?
1x, 2x.
Okay, if y is uv, then y is ln x times 2e to the x. Is that a better visual? Does that help you know where to go here? So now when I go to do y prime, okay, what are you doing here? Okay, and what is the derivative of natural log of x? Do we remember? 1 over x, good. And then we're going to say, what? Times 2e to the x, so she's keeping that second part. Okay, good, so derivative of the first, keep the second, and then plus, good. Okay, keeping natural log of x this time, and derivative of 2e to the x? 2e to the x. And I guess I kind of flipped that because in the past I would have said derivative of 2e to the x, keep natural log of x. Either way.
It always just says,
Yeah, my brain does the first one first every time, whether it's the derivative.
And that's fine. Yep. Yep. And honestly, I say it makes sense to me. I get it. So, let's see. Clean up. If there's a couple different ways we could write this. I would not leave ln x 2e to the x as is. That's kind of like when I have sine x and cosine x. I don't like to have stuff after them because is it part of the inside of sine and cosine? Is this part of the inside of the ln x?
Well, we can factor out 2x.
But exactly. There is a GCF of 2e to the x. And if I factor out a 2e to the x, what remains? 1 over x plus natural log of x. Okay. Shall we move on? You guys can go ahead and try the next one if you want while I move my screen. Okay, example 4. Did you start it? F of x equals e to the x cosine x. It says determine f prime of 1.2. Well, what are you having to do first? Before we can find f prime of 1.2, we have to find f prime of x, right? You have to find the derivative. So, okay, derivative of e to the x cosine x. What are you doing? Okay. Derivative of e to the x is e to the x. Keep cosine x as is. And then plus. So if we're going to, this time, keeping e to the x as is, and the derivative of cosine x, negative sine x. If we were just writing the derivative as is, okay, not having a number to plug in at the end, what would be a nice cleaned up version of this? Factoring e to the x out. And so a cleaned up version would be e to the x times cosine x minus sine x. And there is an advantage to that, because if you now have to plug this into your calculator, it's easier to plug that into your calculator than having to type things multiple times, isn't it? Okay, which I'm kind of giving away. I'm not done here, right? How do I find f prime of 1.2? You're plugging it in. So, e to the 1.2 times cosine of 1.2 minus sine of 1.2. Is this radians or degrees?
No, radians, it doesn't say.
It doesn't say degrees, so it's radians. So if I plug this, e to the 1.2 parentheses cosine 1.2 in parentheses minus sine 1.2 in parentheses. What'd you guys get? Negative 1.8914. Are we okay with that? Question here. Yes, we're practicing the product rule, so yes, I made you do this the long way. We had to use the calculators anyway in the end. What could we have done here? Because I know I've showed this to you on the calculator, haven't I?
Yeah, we can do the indirect thing.
Yeah.
Put that function and put that as a value.
Just kind of, this is a reminder here, right? That if you would have gone, it's up in one of the alpha menus. It's up in alpha F2, it's number 3. But I tend to just go to math because I remember the math button better on this one. So math number 8 is inderiv. So it'd be d dx. And then, now note, we don't put the derivative in, do we? We put the original function. So you would put that e to the x times cosine x. And then when it says x equals, you'd put in 1.2. And your answer should be very, very similar. Mine is slightly different. But that's just a difference of the calculator, so. Okay, so you might practice that. Just make sure you remember how to use the calculator, because we haven't done a lot of derivatives on the calculator, but Okay. Example 5. Let s equal x squared y cubed. Find ds.
That's a differential.
Yeah, remember learning differentials? That was just Friday, wasn't it? I think.
Friday did we do this?
Oh, yeah, we did it for house.
Okay. Valid point. It was Thursday then. Oh no, it was recently. That's what I know. Okay. So differentials, there's two different, well, no, not really. Not two different ways we can do this one. Because here's the deal. I was going to say, okay, we could just go ahead and say, okay, like ds over something, and then multiply that denominator over the other side. But here's the deal. We're doing this equation in two variables, aren't we? So this is where we're going to do the differentials. Whatever you take the derivative of, you put the corresponding differential with it, which is one of the options I showed the other day when we learned this. So, okay, s. And I always skip over, like when it was y earlier. What's the derivative of y? Well, the derivative of y would be 1, right? But we say in that case was y prime. If we use differentials here, the derivative of s is 1. What term did we just take the derivative of? An s term, so officially that makes it ds. Now, obviously, it's the point of the day, right? This is x squared y cubed, so we're going to use the product rule. What are you taking the derivative of first? Okay, so what is the derivative of x squared? 2x. Because it's the x term we're taking a derivative of, we're going to say times dx. And then what do we have to keep? Keep the y cubed. Okay. Sorry, I couldn't stand my little 3 that didn't look like a 3. So we did derivative of the x term, 2x, times the dx, because it was the x term, and then we kept the y cubed. Product rule says we then add. Now what are we doing?
So you would do x squared 3y in the second, but then since it's a y value, would you do dy?
So we're going to keep the x squared. So that's the first one. Derivative of y to the third. So bring the 3 out front. Y, subtract the power, 3y squared. Since we took derivative of the y value, then we're going to say times dy. Okay. Yeah, the only other thing I did is I kind of cleaned this up in that the differentials you tend to put at the end of each term. So when I clean this up, ds equals, I would have said 2x y cubed dx plus, then over here I'd move the 3 out front and say 3x squared y squared dy. That would have been my cleaned up version there. Okay. And I don't know if it helps as a side note here, but to kind of tie it back to last week. If this had just been s equals x squared, we could have done this where, okay, the derivative of s with respect to x is ds dx, and we could have had the dx on that side. And then the derivative of x squared is 2x. Realizing, though, if it's ds divided by dx, you can multiply the x over. And so ds is 2x dx. Okay, as I said, in this one we didn't really have that option because we had x's and y's we were working with. So, point is, you can jump or you could go the long way in certain problems. Okay, derivative of s was ds. Derivative of x squared, 2x. Since we took the derivative of the x term, dx. I don't know if that helps with some connections or not there, but Okay, what do we have? One more example? Let y equal s squared sine t, find dy. Notice we have s squared and sine of t, which means we have to use differentials like earlier, right? So what is the derivative of y? Dy, I hope. As in 1, and then dy. Okay, s squared sine t. Take the derivative of first term, so derivative of s squared is 2s. Since we're working with differentials, I'm going to say times ds. And then we're going to keep the sine of t. It's product rule, so we're going to say plus. This time we're going to keep the s squared. Derivative of sine of t is cosine of t dt. Is with respect to the variable t. I say I probably did not, yeah. Because it was only s. I didn't do a GCF here, I just cleaned it up. So I'm going to say 2s sine of t ds plus s squared cosine of t dt. And you said this is only one page, right? Yeah, because actually that's all I uploaded this morning was one page, so it better just be one page, otherwise I'm in trouble. I'm missing my backside here. Okay.